Hello physicists, in this video what we're going to be doing is studying average velocity. Okay, so velocity is the rate at which the position changes over time. Speed, on the other hand, the average speed, or just speed, is the rate at which distance changes over time. So let's just go through quickly. Let's go through quickly what the difference is between position and distance. So let's have a car. Let's have our building. Okay, and let's have you. You are here. Okay? You are here. Now, this is your reference point. Okay? This is your reference point and you are currently here. Your initial position vector is this way. Now, let's say you walked some amount of x this way, walk this way, and then you walk back to your initial position. Okay? Over some time t. Okay? So you walk to some place, you walk to a building to do some business, then you walk back to where you were before. Okay? Now, the change in position over that time t is RF minus RI, right? So just what we did last time, which is equal to, now because the final position is the same as the initial position, the change in position is 0, even though you clearly moved to the building and back. Okay, so you clearly moved somewhat, but relative to where you were before, you still ended up at the same place. You came, but then you came back as well. Your distance is the total amount of ground you've covered. Okay, so if you walk x meters this way, then x meters that way, then you've traveled a total of x plus x equals 2x meters. That is your distance. So your distance, if you move at all, your distance is always non-zero. Your change in position can be zero in certain situations, but if you're moving, then your distance cannot be 0. Okay? And your speed is at the rate at which distance changes over time. The velocity is the rate at which position changes over time. So now that we've got that out of the way, let's actually look at what average velocity is defined at. So your average velocity is equal to the change in the position vector over the change in time, or time interval. And your speed, I'll just say s, is just your distance over the time interval. Okay? Now let's go back to our position versus time graph again. Okay, so this is your origin, this is the t-axis, this is your x-axis. Now let's say your position looks like this. Okay, this is your journey. Okay, your initial time, your initial time's here, and your final time is here. Okay, your final time is over here. That means your t initial is here and your t final is here. So you know your time interval, tf minus ti. Okay, that is your time interval. You also know that your initial position is over here and your final position is over here. Okay, and this vertical distance is your change in x. Now, how do we represent average velocity on this graph? Okay, well, average velocity will be defined as the slope of the line between them. Okay, so let's do that in a more clear color. Your slope of this line is your average velocity. Okay, the slope m is equal to the average velocity, which is equal to delta x over delta t. So it's the magnitude of the average velocity is equal to the slope of the line between them. Okay, it's equal to the slope of the line that connects those 2 points. Now, let's see our earlier scenario. Okay, what if our final time was instead here? Such that if I were to, it landed at the same initial position. Okay, so time still increased. Okay, so TF2. Okay, now what's the slope of the line between our first point and our second point? Okay, it is 0. So our velocity, or average velocity, the magnitude of it is 0. So it sort of supports our thing that it measures the change in position. Okay, so the velocity can equal 0 even though you've moved some distance. Even though you've moved some distance. Now, let's look at an example. Again, on a number line. Let's go back to black. Let's go back to our flat ground. With our building over here and your person. Okay? Now, let's say your person was here initially. Okay? It was here 200 meters away to the right of the building. Okay? Your initial time, okay? Sorry, your initial time, you start at 0, okay? So you start your stopwatch at when you're here. Now you walk over here. You walk over here. so that you're 500 meters to the left. To the left of your reference point. Let's not make it 500, let's make it 50 so it makes more sense in our diagram. Okay, so if we had 200 meters, 500 meters. Then, after that, you returned. Then you go back, you go to the reference point, exactly at the reference point. So, my question is, if you start here and your entire journey took 3 minutes, first I want to know the position vectors, initial and your final. Then I want to know your change in position over that time interval. I also want to know the length of the time interval. Okay? I want to know the average velocity and the average speed. So we have a lot of things to do in this. Ooh, my battery's running low. So let's try to hustle it a bit. Okay, so our initial position is here. Okay, so relative to our reference point, initial position's here. Okay, so our initial position is equal to, well, first we need to define what is our I direction. So let's make our I direction towards the right. Okay, so your initial position is in the same direction as your I. So it is 200 meters in the I direction. Your final position, well, you end up finally at the reference point. So it is 0. Okay, it is 0. Now the change in position is equal to RF minus RI. So that is equal to 0 minus 200 meters I. So that's negative 200 meters in the I direction. Okay, so it is this way. Your total change in position was this way. Now, I told you that it lasted 3 minutes. 3 minutes, so 60 seconds. Seconds is our SI unit, so seconds, 3 times 60 is 180 seconds. Okay, now your average velocity. So your velocity is equal to your change in position over the time interval, or change in time. Okay, so it is negative 200 meters I over 180 seconds. Now what do we get as a result? Negative 200 over 180 equals negative 1.11 meters per second. And velocity is a vector. Okay, there's a reason why there's an arrow. So it is in the I direction, but it is leftward because our original change in position is toward the I. Now, we have the velocity vector and it points towards the left. So let's add that to our vector. Okay, and what is our average speed? Okay, so our average speed is equal to our distance over our time interval. What's our distance? Well, it is, we went 200 meters. 200 meters. We went total of 250 meters to reach our second position. And then we went And then we went 50 meters more. So we have 200 plus 250 plus 50 equals 500 total meters of travel. So we have 500 total meters of travel over 180 seconds. And what do we get as a result? We get about 2.78 meters per second. 2.78 meters per second. That is our average speed. So notice that it is different from the magnitude of our average velocity. Okay, and that's because our average velocity dealt with our change in the change in our position vector, while the speed depended on the total distance, the total amount of ground we covered during our period of motion. Okay, so we're gonna end it there for now. Okay, if you have any questions, just let me know. Thanks for watching, and see you next time.